Calculus kids, this is Dr. Callahan and welcome to week 12 Monday. So we finished another week and we're starting all over again. So take a moment to go ahead and answer the following questions. All right, let's go ahead and take a look at question number 3. So you are to find the first and second derivative. So the first derivative is p prime of t. So that's going to give you a 3. Now this is, think of it as u. If let u be 4t, then you should see that u prime is going to be just 4, okay? So then sine u, the derivative will be cosine u times u prime. So then the derivative of that, if I replace everything back, is cosine u, which is cosine 4t, times u prime, so times 4, plus 100. Okay, there's your first derivative. Pretty simple for the most part. Now for your second derivative, derivative 3, or excuse me, that gives you a 0, sorry. 0 plus, now here you should be able to rewrite it as 4 cosine 4t, okay? And so you could leave that 4 right there because it's just a constant. So let's say u is 4t, then u prime is 4. So then when we do cosine of u, that is going to be a negative sine u times u prime. So it's a 4 times negative sine u, which is 4t. Wait a second, negative 4t sine 4t times u prime, which is 4. And so then at this point, if you reduce it, you're going to have a negative. This 4 and that 4 gives me a negative 16 sine 4t, and that is your second derivative for this problem. And that's your answer. All right, let's go ahead and move on forward. So looking at this here, it is important that you guys make sure you are doing your assessment. You have an assessment every single Wednesday. So the last couple of weeks, last week was week 11, Wednesday, you had your question on the AP College Board, and it was 9 multiple choice question. It is always due at 11 p.m. on Tuesday, so you have about like 1 week. Then before that, you have week 10 Wednesday, and then before that, week 9 Wednesday. Okay, so make sure you are doing this. And even if it is due, like for example, if you're still working on week 10 Wednesday and it is due last Tuesday, you can still do it, but there will be a penalty of a percentage off. And if you don't do well on it, you can always do a quiz correction or assessment correction, and then you get half the points back. So make sure you are on it. And then this week we will have week 12 Wednesday, and you will have the questions for this week as well. Because we don't have tests in this class, you only have assessments. So it's really important that you are on top of submitting these items in on a Wednesday weekly basis. And if you're like, I don't remember what week 9 Wednesday was, make sure you go to the YouTube channel for the class, because I do describe to you on the channel, on the video, of what you're supposed to be doing for that one specific day. So make sure you guys are on that. All right, so let's go ahead and get started with today's stuff. So last time I saw you guys, I also gave you this part right here. In addition to this, I also included the answers with it. Make sure you are working through this, looking at the implicit differentiation, or even finding like the slope of a curve or the tangent line. That's not anything new. Finding a second derivative is not anything new. So make sure you guys are on top of it. Here is a breakdown for today. We're actually going to start Unit 3. which is a new chapter. And we're going to start it in November, and it's in till December. You guys also have your final in December. A few of you guys did ask me in regards to, do you get to have 1 page of guided notes? You guys can actually use any of your notes that you have collected for this class on the final. And the reason for that is because everything leading up to the AP exam is simply for practice. So it's not meant to be punitive in case you don't memorize it. You're absolutely welcome to use your guided notes. And so it also gives you the incentive to make sure you're watching the videos and filling out the packets. On the actual exam, what you're going to find out is that the questions are so fast that you really are not going to have a ton of time to go through your notes. So when you're practicing with this and you're going through your notes, you're going to realize that it's actually taking you back a lot further than if you were just to memorize the steps and practice with it. And it's actually a lot easier to do it that way than to go through your notes. Also, if you are curious as to what the study guide will look like, I will be giving you guys more study guides as we get closer to that. Of course I am. But if you would like something ahead of time, all you have to do is just to go to Google. And you're going to Google Dr. Natalia Callahan. And from there, you guys have the website. Just click on the first one, Calculus Fall, so click on that. And then if you look on the left side right here, do you see where it says Final Exam Study Guides? So go ahead and click on it. And there are 2 pages for the study guide, page 1 and page 2. If you need any of the formula summary cheat sheets for the fall semester, please click below. So it says you're allowed to 5 pages summary formula sheet, but quite frankly, you can print as many as you want. So whatever you bring to the day of the final exam, you're welcome to use, with the exception of another person taking the test with you, or if you're texting somebody else for the answers, which quite frankly, if you're gonna go through that much effort to do it, you might as well just study for it. I mean, I can't imagine anyone doing that. So if you click on the first link, here are the reviews that I've used in the past, so you can take a look at that. And then also the study guide, page number 2 as well. And you have a bunch of stuff as well here. So you're welcome to do whichever one you want. And they're all fair game, in a sense that on the AP exam, there are tons and tons of different variations, so I would just highly recommend that you study them. All right, so let's go ahead and get started with today's stuff. So turn over to this page on week 12, Monday. First thing I'm going to have you guys do is take a look at the breakdown of Unit 3. These are some of the problems that we will be dealing with, some of the vocabulary and concepts. Optimization problem is the last unit, and they are fairly difficult. They're like related rates. They are word problems using calculus. And I don't know, I think they're probably around the same level of difficulty as related rates. And I told you that it doesn't get harder than related rates, and it doesn't. But these questions are pretty they're pretty creative in the way that you set up as well. And then we'll talk about differentials. And then we are done with Unit 3, and we'll move on to Unit 4 into second semester. So you have a calculus puzzle, why was polynomial afraid of finding her second derivative, that you're welcome to do. This is going to be your notes in class, followed by 3 different examples that we'll be going over. All right, so with that said, let's go ahead and get started. Okay, so first things first, I'm going to go ahead and have you guys take a look at this page right here. Go ahead and read that to yourself. Identify what is a relative max and a relative min in relations to absolute max. I mean, if you look at it, the absolute max is the biggest maximum out of all of the relative maximum. And I would assume that the relative or absolute minimum would be the biggest minimum of out all of them. Next, I'm going to have you guys read the steps on finding the critical point. What the critical point is that when you have max and min, the critical point are these little points right here. It is essentially when the slope is equal to 0. But when you have the slope equal to 0, you're not sure if it's a maximum or if it's a minimum. So you will have to test the slopes. And the reason why you have to test the slopes is that if you have a positive slope followed by a negative slope at a critical point, then you know that this obviously is a max. However, if you have a negative slope followed by a positive slope at a critical point, then if you look at the shape of this, it's obviously a minimum. So you won't know it's a max and min until you test the critical point. So here are the steps. Go ahead and read that. All right, so then let's go ahead and take a look at the examples right here. Okay, let's take a look at example 1. So it says find all the critical points. What are the values of the absolute extremas? And before I do that, I want to get rid of that sign right there because it's bothering me. Sorry. When I get rid of, oh no, 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 I don't want that. Okay, there we go. That's much better. Sorry. Certain little things just kind of annoys me and I'm like, I don't really want that there. It just needs to go away. Okay, so then looking at this right here, step 1 is going to ask you to find the critical points by setting f prime of x equal to 0. Okay, so let's go ahead and do that. So first we're going to find x prime of x. So it's just the power rule, 12x minus, or to the third power, minus 12x squared, and then let's set it equal to 0. This is the slope. You're setting the slope equal to 0 because you know the critical point is either going to be at a max or a min. Your critical point here for the max and min is when slope is equal to 0. So it makes sense to set your slope equal to 0 so that way you can solve for x. So then let's go ahead and solve for x. Here I can factor out a 12x squared, which will give me a x minus 1 equal to 0. On the left side, you do have an x, so if I were to set this equal to 0, divided by 12, 0 divided by 12 is 0, square root of 0 is just going to be x equals 0. And then your second part here is x equals 1. So you actually have two critical points. Two critical points. There we go. So then how do I know which one is going to be the max or which one is going to be the min? Well, if I can find the y values, like if this is my graph, okay, if I plug these points into f of x, which is going to give me the y values, I would know that the highest points here and the lowest points will give me the max or min. So let's do that. I'm going to plug in f of 0, f of 1, or actually that's it. And another thing is, it says it's on 0, 2. So if it's between 0, 2, and let's say, for example, that this is your x-axis, this right here is 2, and this right here is 0. You want to test both of the endpoints as well, because look, this endpoint is at 2, but it's also a min. So if you don't test the endpoint, you wouldn't know that this could potentially be the lowest point and indicate a minimum because your 2 is right at the cusp of that. So then you also have to put in 2 as well. So include all your endpoints and then also your endpoints and also your critical points, okay? So what I would suggest doing is on your TI-84, you wanna do y equals 3x to the fourth minus 4x cubed, hit graph, and then you want to go ahead and take a look at the graph itself, but then do second calc, and then type in the values of 0, 1, and 2, and then it should give you the answers, rather than putting, let's say, the x value here and here, because we want to minimize the chances of making mistakes and errors. Your y value should be 0, -1, and 16. So then looking at this, which is your highest point? 16. So that's your maximum. And then where is your lowest point? Right there. So that is your minimum. All right, so take a moment to absorb that, and we'll go on to the next question. All right, now if you were to go ahead and check your answers, although I have to say on the exam, you probably won't have time to do that because everything goes pretty quickly in that sense. But if you do have time, you can go ahead and graph this function, f of x. And if you look at it here, it's saying that your maximum is going to be at a 2 comma 16, and your minimum is going to be at a 1 comma -1. So let's take a look at that. 1 comma -1, that is your minimum. Your maximum is at a 2 comma 16, and here's my 2, and 16 is all the way up here, and I don't think you see the whole thing because it's still going, but that's what you will have. Okay, let's take a look at example 2. So for example 2, going by the steps, you want to go ahead and set f prime of x equal to 0. So let's first find f prime of x. You will have to use the chain rule. So bring down to 2/3 x minus 1 minus 3 over 3, which is a -1/3, times the derivative of x minus 1, which is just 1. So I have 2, 3, x minus 1 to the 1/3 equal to 0. So in this situation, how would you go about finding your critical point? Well, I'm going to put a 1 underneath it right there, and I can go ahead and cross multiply. So 2 times 1 is a 2. Well, actually, no, that would not be good because I have 0. Um, hmm. Okay. I don't want to do it that way. Let's see this way perhaps. Um, if I want to get rid of the 2/3, I will multiply both sides by 3 over 2. Okay, that cancels. I have 1 over x minus 1 to the 1/3 equals 0. Then I want to I guess I could go ahead in a sense. Let's see. 3x minus 1 equals 0. If I were to bring this up, I'll have an x minus 1 to the -1/3 equals 0. So if I want to make this into a 1, if I were to multiply that by a -3 over 1, then I will have a positive 3 over 3, which is a 1. So if I were to go ahead and do that, that part will cancel. X minus 1 equals 0 to the negative 3 over 1 is still 0, unfortunately. So then x equals 1. Okay, so that was a little bit tricky. So x equals 1, okay, and then you have your critical point. Step 2, plug all the critical points and endpoint into f of x. So I have f of negative 1, which is an endpoint, f of 0, which is a endpoint, and then also f of 1. So use your graphing calculator, do the second calc option. You will find out that when f is at negative 1, you have a cube root of 4. And then when you go ahead and put in 0, you have a 1. And then when you have f of 1, you have a 0. Or is it a 0? No, it's not a 0. What would that be? 1. I guess you'll have like a 0 to the 2/3 power. And I'm not quite sure. Does that give you undefined? I'm not sure. I don't have a calculator in front of me, so I actually don't know. Let's see if I can Google it. So let's see, 0 to the, can't find my little, there we go, to the 2/3 power is equal to, I think it's gonna give you a 0, is what I'm thinking. I think it is. So then it is given to you that your absolute maximum is gonna be right here. So that's your max. Okay. And your max is gonna be at, I'm just gonna write it over here. Max of x value is negative 1 comma y value. And then your minimum is going to be at 1 comma 0. And that is your answer. Oh, you know what? Hold on a second. Negative 1, 0. Okay, so you technically that would be your minimum, but here's a problem. And I was like, this is not working out. It's on the endpoint x1, x2. So you can include the negative 1, 0, and here's 1, but that window here is only between negative 1 and 0. So you can't even use 1 as your critical point because the window eliminates that. So then essentially, this will be your absolute minimum, but because the window is restricted to 0, your minimum is going to be at 0, 1, which is right here. And that one was tricky. Yep. So anyways, that's your answer. So be careful with that. And if you want to graph it, this is what the graph will look like. All right, last one, example 3. We're going to go ahead and set up f prime of x equal to 0. So first things first, let's find f prime of x. But before we do that, you can't do it because you have a square root. So f of x, let me rewrite that, is equal to 4/3 x times 3 minus x to the 1/2. And you probably will have to use the product rule on this because I don't know how you will not be able to do it. So let's set it up. F equals 4/3 x, f prime equals 4/3. G is going to be 3 minus x to the 1/2. G prime is going to be 1/2. 3 minus x to the negative 1/2 times the derivative of negative x, which is a negative 1. So if I were to rewrite this, I will write it as a negative 1 over 2. 3 minus x to the positive 1/2 if it's in the denominator. So then f prime of x is going to be f prime times g. Yep. F prime times g, which is equal to 4/3 times 3 minus x to the 1/2 plus f times g prime. So that's a negative. Well, that 4 and this 2 will cancel to a 2 on top. So 2 times that 1 is a negative 2 over 3. X is on top. And then you have 3 minus x to the 1/2 on the bottom, equal to 0. All right then. So then I'm going to go ahead and move this over to the right side. So actually, I'm going to keep that on the left side because this is a negative. So let's move this over to the right side. 4 over 3, 3 minus x to the 1/2 equals a positive 2x over 3 times 3 minus x to the 1/2. Let's cross multiply it. So I have 4 times 3, which is a 12. 3 minus x to the 1/2 times 3 minus x to the 1/2 is the same thing. Remember, if you have a to the second times a to the third, it's a to the fifth because you add them. So here you have 1/2 plus 1/2, which is a 2 over 2, so it's a 1 power. So just 3 minus x to the 1 power equals 3 times 2x is going to give you a 6x. Let's distribute this. 36 minus 12x equals 6x. Add the 12 on both sides. 18x equals 36 divided by 18x equals 2. So that is your critical point. And is the 2 in between the endpoints so we don't make the mistake we did like last time? Absolutely it is. So let's go ahead and check. F of 0, f of 2, f of 3. Plug that into your calculator. And you should have a 0 for 0, 0 for 3, but then you're going to get an 8 over 3 for 2. So what that tells me is that your absolute max is going to be on 2, 8 over 3, and you have your minimum as 0, 0, and a minimum at 3, 0. And that is your answer, you guys. All right, so then what I would like you guys to do right now is go ahead and I would like you guys to do a little bit of practice for this one. And if you need some additional practices, I have the textbook work right here that you can do. But more so than that, you also have this question over here for that calculus puzzle. All right, you guys, I'll see you guys next time. As always, stay safe and healthy and make sure you finish your assessment. All right, take care. Bye-bye.